In the previous lesson, we learned about binary search as an efficient algorithm to find or search element in a sorted data, in a sorted collection. In this lesson, in some real code, we will see how to implement binary search, and we will also see what are the common errors that happen while implementing binary search. But before that, a quick recap. Let's say we have a sorted array of integers, something like this. The elements are arranged in increasing order, and the size of the array is 6, so the indices are from 0 to 5. Now let us say we want to find out whether the number 10 exists in this array or not programmatically using binary search. Now in binary search, what we do is we take two pointers, two variables that initially point to the first and the last element in the array. We may call them start and end pointers. We may call this variable start and end, or we may also call these low and high to mark the lower index and the higher index. Now start and end, these two variables at any stage in our algorithm give us the range in which the element may exist. So at the start of the algorithm, the element may exist anywhere within the array. So that's why start and end are pointing to the first and the last element. Now we calculate middle point using the equation middle is equal to low plus high upon 2 or start plus end upon 2, and we take only the integral part. So here 5 plus 0 upon 2 would be 2.5, and taking the integral part will give us this index 2 as the middle index. So we are searching for number 10, and initially we are in a state where lower index is 0, higher index is 5, and so mid index is 2. Now we see that whether element at the middle index is the desired element. If it is the desired element, our search is over. So the element at the middle index is 6. Is 6 equal to 10? No, it is not. Now we see whether this element is greater than the target element or less than the target element. Now 6 is less than the target element, which is 10. So we discard 6 and all the elements before 6 because they are also less than 10. And we shift start to point at index 3. So we go to this state, lower index 3, higher index 5, and now we search for our number in this part of the array only. Now if we calculate mid, then mid is equal to 4, 5 plus 3 upon 2. Is it equal to the target element 10? Yes, it is equal to. So we have found our element. Our search is over. We found 10 at index 4. Okay, what if we were searching for the number 9 in the array? If we were searching for 9, till this step it would have been the same thing. Now at this step the middle element is 10, we compare it with 9, and I'll also modify it here. Now 10 is greater than 9, so definitely 9 can only exist before 10. We need to discard this part of the array, and we need to go to a state where our search space is defined by low equal to 3 and high equal to 3. Now 3 is both low and high, and mid element of this range would also be 3 only. Now this mid element is also not equal to our desired number. 9 is not equal to 8. Now once we have only one element in our search space and we have still not found our desired element, our search is over and we could not find the element. Let us now implement binary search, and I will write a C program now. Okay, so what I will do here is I will first write a method named binary search that will take an integer array. Its size, let's say the size of the array is n, and let's say the element to be searched for is x, and this method returns an integer which will be the index of x if it is found in the array. Now we will declare two variables, low and high, and initialize them to 0 and n minus 1 respectively. Low and high at any point give us the segment within which x may lie. Okay, so now we declare another variable mid that is calculated as low plus high upon 2. Now we compare x to the element at index mid, and there can be three conditions here. First condition will be when x is equal to the middle element, the element at index mid, and in this case our search is over. We will simply return the index mid, and when we return from a method we exit it. Now the second case can be when x is less than a mid. Now because x is less than the middle element, it will lie before mid. So now we redefine our segment by shifting the higher index to mid minus 1, and this should be else f. Okay, and the third and the last condition, which will be the default condition here, when x will be greater than the middle element. In this case, we will redefine the segment by adjusting the start or the lower index, and lower index will be equal to mid plus 1. Now we need to keep repeating these 3 steps again and again. So how do we do that? So we will definitely need a loop. So we will put a while loop here. Now when do we stop executing these steps? We stop either when we find the element, so either when we return, or when we are done looking at all the elements. So I will put a condition here, while low is less than or equal to high. When low becomes greater than high, then the segment defined by low and high will not be a valid segment. When low is equal to high, then we will have only one element in the segment. Now if we exit this while loop without returning anything, then we can say that the element x is not in the array. Let's say we return -1 to say that x does not exist in the array. Okay, so this is the binary search method, and let us now write the main method and try to use this function. In the main method, I will first declare and initialize an array. Let's say the name of the array is A, and we fill some elements into this array in sorted order. Remember, the array being sorted is a precondition for binary search. Okay, so this is an array of size 8. Now let's ask the user to enter a number that we will search in the array. So we will write a printf statement here, and now let us take input of this number. Now I will call binary search to search whether this number exists in the array A or not. Size of the array is 8, and we want to find out x. Okay, I will rather name this as x because we have been naming the target element as x throughout. Okay, so now if index, which is the return from the method binary search, is not equal to -1, then we have found the element x in A. So at this stage we will print something like number x is at index. Index is the variable name as well. Else we will print that we could not find x in the array. Let us now run this program and see what happens. So we are asked to enter a number. Let's say we want to search for number 15 in the array. Okay, so this says that number 15 is at index 6, and let us now try to search a number that does not exist in the array. Let's say we want to search for 18, and the output is number 18 not found. There are some common errors that happen in binary search implementation. Resetting these indexes low and high should be done correctly, and we should always be careful about this exit condition from the loop. One more common error is when people do not put this bracket here. Now what will happen here is that the precedence of division operator is more. So high by 2 will be calculated first, and then it will be added to low. So this bracket is important. We need to put this bracket here. And some people also calculate mid as, instead of calculating it as low plus high upon 2, we also calculate it sometimes as low plus high minus low upon 2. And this is a better way of doing it, because sometimes low plus high can exceed the maximum value that an integer can store. So like a 32-bit integer, a 32-bit signed integer can store maximum value of 2 to the power 31. Now if both low and high are pretty high, then high plus low will exceed 2 to the power 31 and cause issues in our program execution. It should be pretty evident that this expression evaluates to high plus low upon 2 only. The only difference is that we are avoiding overflow by not calculating high plus low in this expression. Okay, so this was binary search implementation, and in this implementation we have used loop. So we have written an iterative implementation. You can write binary search using recursion also. I would recommend that you try that on your own. In the coming lessons, we will see more variations of binary search and its application in other scenarios. So thanks for watching.